So on number 21, it says, what's the system of equations that represents this graph? And really what you're doing is you're actually just looking for what are the two equations that make up this graph. Let's start with our equation for a circle. We're going to go ahead and start our bracket here. But off to the side, to write a circle equation, we need to know the center and the radius. So the center they've marked here for me at -2, 1. And the radius, we just count from that center to a side, any side. So let's count up. So we count 1, 2, 3, 4, 5. So the radius is 5 units. So now we can write our equation in standard form. So inside opposite, so x plus 2 squared added to inside opposite y minus 1 squared equals r squared. So 5 times 5 is 25. Now we also need to write the equation of this line right here. We want to know what m is, and we want to know what b is. That's going to give me the information for y equals mx plus b. So the m, if I mark like this point here at the origin and I go up 2 over 1, then that gives me a slope of positive 2 over 1, which is 2. And the b, the place where this crosses the y-axis, is at 0. So now my equation in y equals mx plus b, plug it in. Y equals m, so 2, x plus 0, which is still the same as 2x. So the solution to this system of equation is going to be where they cross and they both have the same point in common. So here I can see it's at 2, 4, but there's another solution. We also want to state this one here at -2, -4. On number 23, it says, what's the total distance around the given shape? Well, if I go ahead and partition this right here, I can see I have a semicircle, and then I need to just find these two sides of the triangle. Let's start with the semicircle. The distance around a circle is called circumference, and so if I'm doing a semicircle, I just need half of the circumference. So if you think about the circumference formula, that is 2 pi r. So we need to figure out what the radius is. Well, looking at this here, if I go ahead and look at where these grid marks would go, which would be here, that's going to be 1, 2 units. So the radius is 2 units for this circle, or the semicircle. So plugging it in, circumference is 2 pi 2, but don't forget we have to divide that by 2 because it's only half of a circle. So that will cancel. And so we've got 2 pi is going to be this part of my circle right there. Then I can count this one here. Starting at this point, that's 1, 2, 3, 4 units. So the only thing left I have to find out is what this length is here. So if I can go recognize here that this is 1, 2, 3, 4 units as well, I could just use some Pythagorean theorem to find the hypotenuse here. So that would be 4 squared plus 4 squared. Those are the two legs, equals my hypotenuse squared. So that's 16 plus 16, which is 32, equals c squared. So when I take the square root of both sides, I think about 32 as being 16 times 2 is equal to c. The square root of 16 is 4, so 4 radical 2 equals c. So now I'm ready to do my final total distance around the circle. That's going to be 2 pi, so that part, plus the 4, that part, plus this part here, which is 4 square root of 2. So in the most exact form, that is the distance around the circle. On number 24, it says a new ride at Six Flags consists of a ring that holds 50 riders. If the center of this ring is at the origin, so we got the center here is at the origin, and one of the riders is on the circular ring, and they're at some point like 16, 15.1, let's call it 16, 15.1, somewhere over here. We want to know what's the distance the rider travels in one complete revolution. So that means we're going to be going like this. That distance means circumference. So we need to figure out what the radius is, and the radius is going to be this segment here from 0, 0 to that point there. So to find the radius, we need to use the distance formula. So one point is going to be 0, 0, and one point is going to be 16, 15.1. The distance formula is the square root of x2 minus x1 squared added to y2 minus y1 squared, and you're going to do the square root of that whole thing. So if I go ahead and say that this is my x2, y2, and this is my x1, y1, let's plug it into our formula. So the square root of x2, which is 16, minus x1, which is 0, squared, added to y2, which is 15.1, minus y1 squared. And so then from here, we're going to clean this up. So we have the square root of 16 squared. And when we do the square root of 16, or, well, when you actually like complete it all the way out, you're going to have 16 squared here, plus whatever 15.1 minus 0 is, which is 15.1 squared. So then from there, what you're going to want to do is plug that into a calculator. So give me just a second to grab a calculator. So here we go. We want to do 16 squared plus 15.1 squared, and that's going to roughly give me the square root of 484.01, and when I take the square root of that answer, that is really close to the number 22. So that is my radius, 22. So to do the circumference, that's going to be 2 pi the radius. Well, I just found the radius to be 22, so that's 2 pi 22, which is 44 pi. But we need to read very carefully here because it says the distance the rider travels in 1 revolution if each unit on the coordinate plane is equivalent to 2 feet. So I need to multiply this by 2. So we are talking about 88 pi feet, essentially, is what we're working with on this particular ride.